Hi guys, I am Riju Sidnai from Group 5 Division R. Me and my group will take you through the topic input and output, and we are sure to make it interesting for you. If you like the video, please don't forget to like, share and comment.
So we'll be starting with modes of transfer. We store the binary information received through an external device in the memory unit. The information transferred from the CPU to external devices originates from the memory unit. Although the CPU processes the data, the target and source are always the memory unit. We can transfer this information using three different modes of transport. The first one is programmed I/O. The second is interrupt initiated I/O, and the third is direct memory access or DMA. So in programmed I/O, the CPU makes a request to the I/O module and then stays in program loop until the I/O device indicates that it is ready for data transfer. This continually repeating program loop is known as polling. When the CPU receives the status as ready, it reads the word from the I/O module and then writes that same word to the memory. It then checks for any other word to be transferred and keeps on repeating the entire process till the entire data has been transferred to memory. So basically this is a flowchart showing the flow of programmed I/O. So firstly the CPU issues a read command to the I/O module. It then checks for the read status of the I/O module. If the status is not ready, then it keeps on issuing read commands to the I/O module until it receives the status as ready. When it receives the status as ready, it reads the word from the I/O module and then writes the same word into memory. It then checks if the transfer of the entire data has been completed. If not, then it again issues a read command to the I/O module, and this process keeps on repeating until the entire data has been transferred. After this, the CPU goes on to the next instruction. So basically, this is what a programmed I/O is.
We will further be learning about the advantages and disadvantages of programmed input output. In programmed input output, the processor is literally responsible for everything. When an input-output instruction comes, the processor sends the control data via data bus to the control register of the input-output module. It then waits for the module to complete its transfer, which is indicated by the status register on the module. So, the register is constantly examined by the processor, and thus the processor is not allowed to perform any other task. The downside to this technique is that it is time consuming. This is actually a hardware pole. The interrupt acknowledge line is daisy chained to all the modules. Whenever there is an interrupt, the processor sends out an interrupt acknowledge which propagates throughout the series of input-output modules. Now we will see an example of unpredictable wait events. Keyboard on a workstation or a PC. Now in this case, the processor has to wait till the user presses a key on the keyboard but respond immediately within seconds to the key press so that the response time is not noticeable to the user. Therefore, programmed input-output is not suitable for prolonged wait states. Next, we will be learning about input-output commands. Input-output commands allow you to own, use, read, write, and close devices. Now, the name of the commands are quite predictable because they resemble the function they perform. What is an input-output interface? An input-output interface is something which provides a method for transferring information between internal storage and external input-output devices. It receives mainly four types of commands: control, status, data input, and data output control command. Next in line is input-output instructions. The main function of input-output instruction is to provide communication between computer and outside environment. There are two main classes of input-output instruction: those that transfer a single item and those which transfer strings of items.
So to conclude, an input device allows data to be entered into a computer system. Some examples of input devices are keyboard, mouse, microphone, scanner, and assistive technology. Output devices, on the other hand, allow data to be transmitted by the computer to the user. Examples of output devices are monitor, printer, speaker, and projector.
So I'll be talking about direct memory access. So it is a computer feature which allows certain hardware to access the main memory of computer independently from the CPU interrupting. So the impetus behind DMA, that is direct memory access, is interrupt driven and programmed IO require active CPU intervention. The second point is transfer rate is limited by the processor's ability. It depends on the processor, the rate of speed of processor to access the memory, and the CPU is therefore managing the input and output. Now we'll talk about how a DMA operates. So first of all, the CPU tells the DMA controller whether it will read or write the operation. Then the address of device to transfer data from the starting address of the memory block. For the data transfer 1, the amount of data to be transferred is detected. Then DMA performs transfer while CPU does other processes. DMA sends interrupt when completed.
So now we will look at interrupt. An interrupt is a way of controlling input-output activity in which a peripheral or terminal that needs to make or receive a data transfer sends a signal that causes a program interrupt to be set. There are two types of interrupt. One of them is hardware interrupt, which is when a signal is received from an outside source. In addition, it has a maskable interrupt and a non-maskable interrupt, which depends on how the input signal is received. The maskable interrupt can enable or disable the interrupt processing freely. However, a non-maskable interrupt cannot be disabled. Next up, we have software interrupts. A software interrupt is when a processor itself requests a software interrupt after executing certain instructions or if the particular conditions are met. These can be a specific instruction that triggers an input and can be triggered unexpectedly because of program execution errors known as exceptions or traps. So now we're going to look at I/O module function. An I/O module includes control and timing to coordinate the flow of traffic between internal resources and external devices. An I/O module communicates with the processor and the CPU to decode commands, exchange data, and report status. The two others include data buffering and error detection. The steps for input-output are as follows. Firstly, a CPU checks device status and returns it. After this, data transfer is done and the module gets it from the device, which it then sends to the CPU.